In this video, let me show how we can install PySN-Digest on a Linux machine. I'm using Linux Mint that is Debian-based on a VirtualBox. So the first things to do is to head to the GitLab repository. So I go to PySN-Digest here, and then click on the blue code button and then copy the URL. All right, let me minimize that screen, and here I'm going to open a terminal on the desktop, and then I'm going to type git clone and then paste the content of my clipboard. Okay, so what's happening is that git clone has downloaded a bunch of files. They are in this folder here called PySN-Digest, and you can see that it has SummaDB zip install files for USB communication for various platforms. But let's open a terminal in this folder. Let's go back to the GitLab repo and take a look at the ReadMe file. It gives you step-by-step instructions, lists the two pre-required software, Python and pip, how to check if you already have them, etc. Make sure you are looking at the section applicable to your operating system, as the script can be installed on Windows, Mac, and Linux. I know that my machine is ready, but to illustrate, copying and pasting, this is how we can see that I have the recommended Python version. I also have the last version of pip 3. If you already know that you have recent versions, that's probably fine. Otherwise, please run these quick checks. Some older Macs have Python 2x pre-installed, which is not compatible. Those would have to install Python 3x. The link is provided in the README. Download Python from the official website and make sure that you also include the path to the executable. Now we can run the setup venv-py, the script that downloads libraries and installs the virtual environment needed for our project. I copied the command instruction on the clipboard, pasted it on the terminal, and tapped enter. If the process is successful, it should have installed the proper platform for a DB for Linux, deleted the zip files, and created a shortcut. And I believe this is the shortcut, and I'm going to just drag it to the desktop. The next important settings is to ensure that your Supernote file architecture matches the folders that the script is going to use. Python expects 3 types of folders, one folder holding the PDF files being annotated, and of course, their associated MARC files. Another folder to output the files that have been processed and still need further annotations. This folder could be the same as the input folder, but we recommend keeping these distinct for now. The third folder is an export folder where Python outputs a PDF built by merging the annotated original PDF with its associated MARC file. These are for pure PDF files that are ready to be file-to-mailed, etc. You could still keep annotating them in the Supernote, but keep in mind that all previous pen strokes have been flattened and are no longer selectable. You can still erase them with Python, but we'll talk about this later. Let's talk a minute about the contents of my Supernote folder. You can see the SD card is here, and on the SD card, I have a PSN input folder containing a PDF file being annotated and its associated MARC file that contains the Supernote annotations. This file is an example of a PDF without any recognition text. Basically a PDF built from scanned pictures with no OCR. The other disk is the internal hard drive. Here, under Document, I also have Python input folder containing a more conventional academic paper that has text selection capabilities. So far, both files have handwritten annotations made within the Supernote. The more recent academic paper also has some various highlights and comments inserted from the Supernote. At this stage, I have not made any PySN-Digest selection. So to recap what is in the input folders, one internal document subfolder containing a classic academic PDF paper and the other on the SD card containing a PDF without OCR. Besides these 2 Python input folders, I have one Python output folder and one Python export folder, both on the internal hard drive. And again, the output folder is for holding modified files in Proses that still contain the pen strokes, while the export folder is for holding the flattened PDF files. Okay, let's go back to the settings here. We want to ensure that Python's folder settings match the Supernotes. There are 4 ways to achieve this. Number 1, maybe the easiest for the demo is to replicate the settings that I have. It doesn't matter if you don't have an SD card. Python will skip folders that do not exist. Number 2, run the program once. It's not going to find the folders I have, but it's going to create a user settings JSON file under SN-Vault subfolder. This is a file where your own settings will be saved. It is small and easy to edit in a text editor. Modify and save. Number 3. Use the command line interface in the terminal. Number 4. If you know what you are doing and familiar with Python, edit the digest.py code. Global variables are in uppercase at the beginning of the file. They have inline comments with hashtags, briefly describing them, and a flag, either an exclamation point or a star indicating whether you should customize the variable or leave it alone. If you go that route, remember that user settings override everything, so you'll have to slightly modify the code, too. Now, let's go back to using the command line interface. One thing super important to remember is to activate Python virtual environment before starting any interaction through the terminal. If you forgot how to activate it, head back to the ReadMe file, copy, paste, and hit Enter. You know that the Python environment is activated when you see that the prompt has changed to PySN-Venv. Okay, back to the using the command line interface. First, familiarize yourself with it by using the Help option. It displays the few global variables that are exposed and the options command to use to set them. For each option, it also shows in uppercase what corresponding global variable is involved in the Python code. Lastly, between the square brackets, it lists the current values. Some examples. If we look at --debug, we see that it modifies debug mode, that encompasses leaving clues about what the script is doing, including files and more verbose terminal. We also see that current value is true, meaning that the script will run in debug mode. It's useful when you try to understand why the program doesn't work. For instance, the input optional parameter affects a global variable called SNIO watch folders, and those are the folders or the PDF that you are reviewing are located. Current values here, 2 folders, including one in an external drive. Whenever you set an external drive value, it needs to start by SD card. Maybe one more thing you see the author here by default is as a Supernote user. So if I want to put my name, I would have to change that. Okay, the only thing I'm going to change here for this demo is changing the author name before launching Python. Remember that debug mode was enabled, so there's going to be a lot of output. The program is launching, and you can see that it connected here on the USB port. Something you probably won't see at first. Python communicates with Microsoft Computer Vision. In the next demo, Python will also send the cropped pictures from the Digest selection. If you'd like this feature, you'd have to either open an account and provision a machine for that task on Microsoft Azure, or modify the code to use similar service with AWS, etc. I chose Microsoft because when I first started to do a comparison for a translation automation project, it was better and cheaper than AWS's equivalent. By the way, I have much more cloud resources with AWS. Anyway, provisioning a machine for that service is super easy, super fast. And I think they don't charge you for the first 5,000 API calls per month, meaning that so far, I haven't paid a cent. Above 5,000, it's something like $1 per 1,000 calls. The other advantage of Microsoft Computer Vision and AWS equivalent like Textract is that the recognition response also includes the coordinates of each text on the submitted picture. Python doesn't leverage that yet, but I do have another demo where the Supernote table of content is generated from the Supernote headers and converted to text. If you decide to go with Microsoft Computer Vision, Python just needs the endpoint to your provisioned resource on Microsoft Azure and an API key, both stored in your machine's environment variable. Oh, one last comment on this point. By default, I introduce a 3 seconds delay to avoid hitting any rate limit. My guess is that it is overly conservative, and you may want to set the AF's wait global variable to something shorter. The exciting results are going to be in the next video, where we are going to select the digests we want, using light gray color, and erase PDF sections, using white color. Python will append digests at the end of the PDF, building links to switch back and forth from the original section of the PDF and the end section where the digest and your additional notes are, add handwritten text recognition, build table of contents, remove the selection strokes because, yes, it does edit and send back an edited mark file to the Supernote. Thank you for watching and please post any comment below.